is medvr.io. So on the screen, I just want to, let me just pop my slide forward just a little bit. There we go. There are more talks, so you can take a look at them. Last year we did some we did a foundational talk that talks about what is VR, what is AR, what is mixed reality, all in the context of healthcare. So every single use case we've presented probably 50 different use cases by now across our different talks, but in the first talk we did a lot of them. So you could go back and take a look at that if you're a newer person in this subject area. And that's medvr.io online talks. So I just want to give a little plug to sponsors. None of this has happened without sponsors, so this is a small list. We've got some others, but if you would like to sponsor us, we would like to have you sponsor us. So it just doesn't happen on its own. Although I would have to say, if you were here a little bit earlier, Steve and myself and others are volunteering 100%. So it's definitely a grassroots kind of thing too. So I think that I will stop sharing my screen. Oops, let me go back up to this. Welcome, welcome, welcome everyone. I'm going to do the official welcome. I already talked a little bit about my background, so we won't go over that and what is MedVR. I want to do a little bit of housekeeping reminder. Please talk amongst yourselves in the chat. We love to have people that come talk to each other, tell us where you're from, tell us what you do. Use the tab on the bottom for Q&A, or on the top, wherever you've placed it, for Q&A to the speakers. And at the end of the talk, we'll get to those. Both of the speakers today, Dr. Linda and Jennifer, have said that they would be able to stay if we run a little bit over and we have some Q&A. So thank you very much for that. So it is my great pleasure. I'm going to launch into the intros, right? So it's my great, great pleasure to introduce our speakers today. Both are innovators in the creation and harnessing of AR to transform medical services in healthcare today. So without further ado, I would like to introduce them. Dr. Linda Bruetzel is the product manager at Brainlab, which is a company that develops and manufactures marketing and markets software for medical technology that enables, I guess, and she's going to talk about it more, very focused on less invasive patient treatments. So this is wonderful. Prior, Dr. Linda was an application consultant at a company that did analysis of imaging. So it seems like it ties directly to her X-ray PhD, work in X-ray and scattering and understanding how to use 3D in that area. Prior to that, she was a product manager at PN Detector, where she worked on the requirements for X-ray and electron detection solutions. And she has, and I love this list, a master's in physics, a master's in biophysics, and a PhD in small angle X-ray scattering with 3D DNA work. So not too shabby right there. So, and then we have Jennifer Esposito, who is the vice president that leads Magic Leap's healthcare business unit. So leading all of the work that they do, and that's really exciting. We're excited to hear about that wide swath. Prior to joining Magic Leap, she had another little job heading up worldwide services in health and life sciences at Intel. So that's a pretty amazing job that you did right there as well. In addition to that, I think it was, she was a co-chair from 2017 to 2018 at the Global Health Security Agenda Private Sector Roundtable. And then prior to that, the executive director of the High Value Healthcare Collaborative at the Dartmouth Institute. She has an undergraduate and a master's degree from Dartmouth College. And I welcome you both, very heartfelt welcome to our talk today.
Thanks, Jill.
You're welcome. I'm delighted to have you here. So just to let everyone know, you will get a chance to ask our experts questions at the end. We're going to move into a nice conversational flow for today, where Jennifer's going to talk a little bit about Magic Leap and Dr. Linda about Brainlab. And then we'll get into the motivation around mixed reality work that they've done at Brainlab and what's going on over at Magic Leap in healthcare, and a talk about the challenges that they face, which we're all really interested in that. Early days in our field. And then we've asked them to take a look at what they see in the future. So I think that's great. We'll have a Q&A at the end. And now I will stop sharing my screen. And without further ado, I will shut myself off and we'll hear from the experts today.
Thanks, Joey.
My pleasure.
Thank you very much. I hope you can see my screen now.
Yes.
Okay, perfect. So yeah, the title of our talk is the journey that we did or do together to move mixed reality from a gaming technology to a medical assistant. And I would like to hand over to Jennifer, who will start.
Yeah, thanks, Linda. And we're looking forward to a conversational discussion here today. So I thought we'd start off just with a little intro about Magic Leap. As Julie said, I'm Jennifer Esposito. I lead the health business here at the company. A lot of people ask us why we are working on health at Magic Leap, and I always like to give the history and sort of the story that it really goes back to our earliest days with our founder. There have been people at Magic Leap working on healthcare and all of the surrounding use cases, ever since the beginning of the company. And so we've been working for quite some time with Brainlab, even prior to the launch of Magic Leap 1 in 2018. So that's sort of the background history. We can go to the next slide, Linda, and talk a little bit just to level set. I know this is an audience that is really familiar with the VR, AR space. But I think what we like to do is just make sure everybody's level set on the definitions in terms of the differentiation between the different types of computing platforms that are out there, right? I think everybody understands when you talk about VR that we're talking about a completely immersive experience where you're not able to see the real world. There's many different flavors today of augmented reality, including the one you kind of see in the middle, which is more the consumer handheld smart device kind of version of AR, where you're really talking about simple overlays of digital content onto the physical world, and you're usually holding some device up. What we work on is sort of the more advanced form of AR, particularly when we talk about our focus on industries like healthcare and other enterprises out there. Our form of technology is really about overlaying the digital content on top of the physical world and being able to see through the device, not need to hold anything in front of you, being fully heads up. And that digital content can be aware of the physical surroundings, and so that you have some sense of what's there, of persistence of that content, given where you might move around to and come back to the space. And so that's why we'll talk a little bit later on in this presentation about some of the additional use cases that we're working on, more broadly speaking, and how we think that fits into the broader spectrum of health, wellness, fitness, and including what we're going to talk about here today, which is really to focus in on surgical applications. So I think I'll turn it over to Linda now, and we can get going on that.
Great. Thank you, Jennifer, for the introduction, and also Julie for the nice introduction as well. I'm really happy to be here today. And before we dive deeper into mixed reality, I would like to take the occasion also to give you a short introduction about our company. So Brainlab was founded in Munich in Germany in 1989 by our CEO, with the aim actually to provide medical software and hardware for oncology and surgery. And what started with great ideas and a few people is actually now a very successful company. So we have over about 1,500 employees that work in 20 offices all over the world. And they are up to date, approximately 13,700 systems installed. Go to the next. So our products are mainly used within the following clinical segments, covering neurosurgery, oncology and radiotherapy, then spinal surgery, but also ENT and CMF surgery. And Brainlab is first and foremost a software company, and our core products center around surgical navigation, radiotherapy, digital operating room integration, and information and knowledge exchange. But over the years, the development of hardware system has always also become quite crucial to our portfolio. You can see here, we also provide imaging platforms, patient positioning systems, intraoperative imaging devices, and very recently also robotic systems that can be used within, for instance, during surgical procedures as in spine. That's basically a brief or a very rough overview about our products. And what makes our company very special, and I think also highly differentiates our medtech, our company from other medtech company, is actually our continuous eager to always look for new digital technologies and how they can be used within healthcare. And a lot of the inspiration actually comes also from our CEO, Stefan Filzmeier. And this, I think, nicely illustrates why Brainlab and Magic Leap now work together to establish mixed reality in healthcare, because we have, on the one hand side, Magic Leap being an expert and also have some background on healthcare with their spatial computing technology, and then our company, which has a long expertise in healthcare and also how to integrate new technologies in healthcare. So let's talk about our motivation to combine mixed reality and surgery. And as you probably all know, medical imaging data are kind of the basis and prerequisite for diagnosis and treatment planning in surgery and oncology. In here, I just have a brief overview. So there's magnetic resonance imaging that is commonly used to visualize soft tissue, but also to do tumor characterization. Then you have computer tomography that is more used in trauma cases or staging cancer. And then you have ultrasound that is there to visualize internal organs. And we at Brainlab focus mainly on MRI scans and CT data. And also for these different imaging techniques, there are different settings that you can choose, or the user can choose, depending on the indication. So the different scanners, then you can run different protocols. For instance, an MRI, you can do a T1 or a T2 scan. Then, of course, you obtain different resolutions. The user can define the region of interest and also apply contrast agent. So this means that the required information, or the information that we want to get, may be spread across different scans. So besides choosing the correct settings, it's also very crucial to do a profound image analysis and to then come to the correct diagnosis and do a surgical planning. Sorry, I just had a message on my computer. And we at Brainlab offer a software suite that is called Elements that allows the surgeon to analyze the data and extract and visualize the functional structures of interest. And here I would like to show you some examples. So there's one software module within Elements, which is called Image Fusion, and this allows the user to rigid or elastically fuse different data sets. For instance, you have preoperative data or intraoperative data sets, or a CT and an MRI scan. And with this software, the data sets are in the end aligned within the same coordinate system. Then we also offer an automatic segmentation of functional structures. Therefore, the patient data are compared to a synthetic tissue model, as you can see here on the right-hand side. And based on that, with a specific algorithm, the structures that you want to outline, as for instance here, they are segmented automatically by our software. And also the corresponding 3D models are generated. And in the end, the user just has to validate the objects. We can only do this in a semi-automatic way. For instance, if we want to outline pathological structures, and how this works, I have here in a little video. I hope this works. So with this little brush, you outline the region of interest. So here it's a tumor, and the software also assists you. This is done in the axial view. And then you have to do the same in the sagittal view, as shown here. Also, again, with a little help from our software. And if you have done this, here on the upper left, you can see the corresponding 3D model. And in the end, the user just has to verify whether the object makes sense, or if he wants to make slight adjustments. But this is much easier because you don't have to go through all the slides and segment or outline manually your region of interest. So as you can see, our software modules are already a great assistance within surgical planning, but a big challenge still remains to get the 3D anatomical understanding out of these 2D data. So if you imagine you are in an OR and you have our nicely outlined and segmented data, you still have to do the transfer, how these actually correspond to the real patient. So the 3D anatomical understanding is highly critical to perform a correct and good surgery. So we ask ourselves, why not generating 3D models and visualize them from these segmented images? And this is what we can do with our viewer, where we can generate really patient-specific 3D models for different anatomical structures, ranging from neurosurgical data sets, or also the liver and then abdominal structures. And this really goes also here, for instance, into the brain. And we launched this product in 2009. So these 3D visualization, but still, I mean, the question remained how to visualize them best and also to transfer the information content best and allows for the best user interaction. And therefore we extended this concept by introducing this with, or combining this with 3D stereoscopic displays. Therefore the user has to wear specific glasses and then he already gets this nice depth into overview or feeling. But this was kind of not enough. And in 2019, we finally launched our mixed reality technology. And this I want to show you here. So to develop our mixed reality technology, we entered into a strategic partnership with Magic Leap. And the current product that we sell consists of a software, the mixed reality viewer, that is made by Brainlab and is CE and FDA cleared, and the head-mounted display, which is Magic Leap 1. And here I would like to hand over to Jennifer again so that she can talk a bit more about the headset.
Yeah, so thanks, Linda. So as I mentioned earlier, we launched the Magic Leap 1 headset in the summer of 2018. And so this is the platform that we've been working on with Brainlab that is part of the solution that Linda just described. And I think, as most of you know, it's a combination of a headset, a computer, and a control. So you have a lot of different options when it comes to leveraging either the control or other input mechanisms, whether it's things like eye tracking, gesture, voice. And so there's a lot of different functionality that you can leverage based on the existing platform. We also released an enterprise version of Magic Leap 1 back in the end of 2019, which enabled some additional functionality, things like device management, so that it would be easier for deployment in scenarios where you need to have multiple devices in a system managed by an IT shop or something like that. So I think you can go to the next slide, Linda.
Good. Let's see. Okay, thanks. So still the question was how to bring now this technology into healthcare. Because at the beginning we were confronted with a lot of skepticism. People thought like, well, it's a toy, or associated this with gaming. And so we thought, okay, if we want to bring this into healthcare, we have to develop several approaches to overcome these concerns and skepticism. And the first thing is, what is very crucial, is that we have to offer an easy and seamless integration into a clinical workflow, because a surgeon will never use this headset if it's not easy to use and can also be integrated in the clinical workflow. And therefore, so after all these planning steps that he did with our software, as I've shown before, he just has to start the viewer, click on this icon, and scan with the headset the QR code, and then the data is transferred to the headset. And how this works in reality, I will show within a short video. So sorry, I will just move this. So you have our viewer with the data, then you click on the Magic Leap icon, put on your headset, use the controller, and then you are free to go. So you can place the object where you want to place it, and then you can move it, resize it. So really go into the brain and walk through the brain as you would like to do it. And then you can turn also an object, rotate it, and this also, if you have multiple user session, you can view it from different perspectives simultaneously. Then you can also navigate through the segmented objects, through the segmented layers. And then you can also do kind of a trajectory plan where you overlay your trajectory and the 3D model with corresponding 2D data. So this is the current product as we have it. There will more features come within new releases. And now I would like also to continue with some other features that we've implemented. So also what I think is very difficult at the beginning, because this whole concept of spatial computing is not very, people are not very familiar with that or don't know how to use it or how to interact. So the positioning and the orientation of objects. So therefore we designed a little marker which has this arrow. It's just a piece of paper with the arrow that you have to place on the floor or wherever you want to have it. And then you just have to align a corresponding virtual arrow with the real world, so to say, arrow. And this is especially beneficial in multi-user session, because this means that this is kind of the coordinate system, your starting point of the coordinate system. And this means that the virtual objects are all aligned to this coordinate system, and the users see them at the same positions. And then also, because I think you can easily get lost within a room, we implemented these transparent guidelines that help and assist the users to orient and also to find the 2D and the 3D data. So you can also think, I mean, this is just one object, but sometimes surgeons also use several objects. And then also what is, I think, very critical is that you provide an easy and intuitive way to interact with the models. So with Magic Leap, we have the controller that has several input signals or ways how to interact with the object. And we also implemented a selection menu. I will just give you an overview here. So this is how the user interacts with the model. You select whatever you want to do. For instance, here, do a measurement. Then you place with the laser a point, and then you do it again on the other side, and then the software provides you the distance. And I think this is also a high benefit thinking about multi-user interaction or sessions, where you really, with this little laser sword, you can really follow what the others are doing, and it's very intuitive to interact with the models, and you can see what your partners are doing. And I mean, there's also, we get a lot of questions regarding with HoloLens, you can do it with gestures, which I think looks nice, but it's especially for multi-user sessions, not super intuitive and easy to integrate. And also after some time, it also gets very tiring when you always have to hold your hands up. And also, if you think in a long-term goal, using it within the OR, people shouldn't, or surgeons shouldn't use it in the sterile field, always having their hands up. So at the moment, we see a high benefit in using the controller and implement it in our solution. Of course, there are still several technical challenges which we are currently or constantly working on and try to improve. So as I already said at the beginning, I mean, it's always a challenge to use the space in an intelligent way. So we all tend, I think, still to think about in a 2D way. So digital technologies always is like computer screens, but now we have to use the whole room and position 3D objects in an intelligent way. Maybe this can be done at some point also automatically by that the headset recognizes the space and then automatically positions the objects in a intuitive way. And then also regarding the multi-user sessions, of course, there we have to make sure that the interaction is seamless and user-friendly, and that it kind of feels also real, that you don't, that at some point you forget that you are actually in mixed reality, and it feels kind of easy as if you would interact with the objects like in the real physical world. So these, I think, are still some points that we constantly are improving. And now I want to switch and talk a bit about our current use cases of this technology and also the experiences. So currently the product is used within surgical planning review, and we got feedback that surgeons use this especially or they take more time with mixed reality now to do the planning, and this leads sometimes also to a kind of déjà vu effect when they are in the OR, that they really remember the 3D anatomical how the data look in 3D, and they can remember very well. And then it's also highly beneficial if you have to plan a very complex case, for instance, an aneurysm planning. There it's very critical to get a 3D understanding about all the vessels going through your head. So there we got feedback that this really makes sense. And also for delicate surgical cases, sometimes MR also shows them alternatives, how to do the treatment, how to plan the trajectory, how to access and do the surgery. Then also we get a big feedback, or a lot of people see a high potential using this in medical teaching. This is already used for resident teaching, but also in the future, we got feedback that this should be integrated more also in resident teaching, because it offers a great alternative to cadaver labs, or like the lab where you anatomical labs. And also the hope is, of course, that residents then using mixed reality can take over some special surgery maybe earlier. And then also patient education. I mean, this is at the beginning, I would say, but we also get the feedback that this is more and more, should be more and more brought into this application. So for instance, we had one feedback from a patient who was supposed to go under surgery where he should have been awake, because he had a tumor in his head, which was at a very delicate position, and he didn't want to do it because it's not very comfortable. And then the surgeon, together with the patient, they put on the headset and they walked through his brain, and afterwards he really got a much better understanding what should have been, or what they were going to do during the surgery, and also why he was supposed to be awake during the surgery. So this is just one example. And speaking about the clinical disciplines, so it's applied in a broad range of disciplines. So CMF, we have some cases, neurosurgery, spine, and also vascular surgery. And of course, the technology, we are still working on, or trying to get, of course, more clinical proof that this technology shows a benefit. And we have published last year, together with colleagues from Munich, a paper about using this technology for the virtual dissection of white matter pathways. Here, just a brief background. The knowledge of white matter anatomy is very crucial for surgical treatment of eloquent gliomas. And to get knowledge about this is almost, or very often, done on cadaver dissection, and these are of course expensive, and we have limited availability. And there we did it now with, we trained the neuroscientists and neurosurgeons using mixed reality, and there in the end they fulfilled or completed a survey which showed after the evaluation that most of the participants rated this as a very promising and beneficial technology. And one use case I want to point out, which was very prominent and I think is also very convincing, which happened at the UC Davis. So there they had these two little girls, which were born as Siamese twins. And the challenge was to kind of separate them. And I think in the whole procedure, 30 surgeons were involved. The surgery lasted for 24 hours. And within the planning, they also used our mixed reality technology. Here you see a picture where they visualized the vessels, which is, I think, very crucial to make sure that nothing happens during the surgery, how to separate them. And what makes me very happy, and also bringing me back, I think, to the title of my or of our talk, is that one surgeon said while using our technology that this is definitely not gaming. So I'm quite sure that we now finally, after 1 year we of our release, we finally achieved that it has an acceptance in healthcare and shows a clear benefit of this technology. And I mean, this is just the beginning. So there's a lot of more applications and a lot of things we can do in the future. And here I have prepared a short video of our vision, and maybe Jennifer, you can quickly comment on that.
Yeah. Yeah, this is a great video to kind of give people a sense of the end-to-end and the longer term vision that we both have here for surgery, right? So it's taking what we're doing today with both planning and surgery outside of the operating room into the operating room, and being able to overlay and register the radiological images on the anatomy to do things like object identification of the surgical instruments and other tools, and to track those, and to really reimagine the different ways that you can display data in the operating room. And so if you ultimately think about replacing all of the physical monitors in the room, you have a real opportunity to think about an entirely new way to display existing data. And that can be data that's both 2D and 3D. And it can be the combination of data that didn't previously exist. And so that's really the long-term story that I think, Linda and I are super excited about, and that our teams are working on in different ways. So I'm going to just kind of give you a picture from our side at Magically, how we kind of see the broader health, wellness, and fitness, market segments, right? We really think about it in three big buckets: med tech, digital health or health tech, and then pharma and fitness and wellness. I really focus in on both the med tech and the digital health side of things. This is where we're doing a lot of work, and it's also the place where we see obviously some of the more complex use cases. But if you think about all of these segments, not only is there a lot of business opportunity, there's a lot of opportunity, just like with the conjoined twinned example that we just saw, right, for true benefit in the form of improved outcomes, increased efficiency for the clinical workforce. There's a lot of opportunity to really both change how healthcare is delivered and practiced, but then also how it's experienced by patients and by students and by researchers. So when we think about these three segments, we also think about some of the overarching use cases that we see cut across, and because there's a lot of similarity in the use cases at a horizontal level. And you'll also notice that when I talk about these use cases, that you'll see that for the most part they also overlap with other industries, right? So I think this gives you a really good picture of where augmented reality fits in the broader ecosystem of various different industry verticals and within the enterprise itself in terms of how people work. So the first use case category that we often talk about is operational use cases, right? So things like command and control, where you're really able to leverage the new type of display to visualize important information, and you can do it without having to look down or look up at and around at a variety of different monitors. And you can also really gain different types of insights from this data because you're able to display it in 3D and in completely new ways. The second area, and this is actually a really big area of focus for Magic Leap right now, is what we've been calling communication, collaboration, and co-presence. And it's really taking us away from the current 2D video conferencing standards that we're all experiencing right now with this session, right, to things that really enable both 3D co-present, avatar-based sharing sessions where people are able to interact with each other in new ways and also able to share digital content in ways that they're not currently able to do on the standard platforms. The other big area is training and simulation. This is really thinking about how you can use augmented reality to really potentially replace some of the more complex, physically based, prop-based types of training and simulation that currently exist, along with your more traditional training mechanisms, right, where you are getting a little bit of additional value out of the 3D content. I think you've also heard me talk in the past about things like digital twins, and this really falls into this augmented workflows and visualization category. It's the ability to map physical spaces and use the information that you're capturing over time to dynamically update, to inform the workforce and amplify their overall potential and capabilities. In the MedTech Summit, where, just like I think we've alluded to with what Linda and I talked about with respect to surgery, right? There's definitely a lot of work going on in how you can really leverage an advanced display and look at use cases that are around tracking, guidance, navigation. And then the last category is the one that really falls very squarely into the digital health segment that we have up in the middle there. These are use cases where we are using our technology to create different types of either diagnostic tools or digital therapeutics that can be used with the patient wearing a device like this. So I think, what you can see, I think from this slide is that there's really a very broad spectrum of use cases that can be applied across multiple different core segments in health. And so I think it's a really interesting time for us because, we're starting to see a lot of really great results in the form of different pilots and proofs of concepts and clinical studies that a variety of different partners are working on across this space. And so I think in the next, 12, 18 months, you're going to see a lot of really interesting stuff coming through. Thank you.
Yeah, thanks a lot. I think that's the end.
Yep, that's good. That's great.
Yeah. So if you have any questions, I think there's now time. And also afterwards, feel free to contact us under these email addresses.
Okay. And thank you guys very much. Like, I think you're the first to fit in the time frame too. So I'm like, yeah. So we do have a bunch of questions. I would like to lead off with just a couple myself. So one of the things that caught my attention, Linda, was when you talked about the physical marker a little bit, because I've been watching the space of using AR during surgical procedures for a while here, and we've had a number of talks here. And the drift topic, I think, has come up in one of the questions in the list, but I immediately wanted to make sure that I was clear on the use of a physical marker.
Yep.
I saw you do the placement on a desk, but the notion, when I'm in theater watching surgery happen, that a surgeon could take a marker, a small marker, and put it somewhere and just tie it down. Like, is that that just seems to be so missing right now. So I'm interested in was I observing that right? Or what's the notion there?
Yeah. So, this is just, you can't compare it to, so this wouldn't be sufficient to place it in the OR for like, generating or make sure that the overlay corresponds to the patient. This is something where we all want to get to
Right.
at some point. And this is just to like, with each, for each user, that they kind of look with the headset, having this virtual arrow in front of them, that they overlay it with the kind of real marker. And this makes sure that, everyone sees the object at the same place, so to say, that we are all in the same coordinate system. But of course, this here we just rely on the head pose tracking of the headset. And there's, simultaneous, or already when you start doing the overlay, you see a little drift. So this will never fulfill the accuracy requirements that we would have in a surgery, and therefore we would need a marker that is recognized by the headset, and this assures a kind of stable overlay with the object that you want to overlay it with.
So I jumped a little ahead in the questions. Looks like John, we have a question from John that's like, how do you mitigate control drift? And so he's asking a very similar thing.
Yeah.
So that's a great question from John in the audience, and I didn't mean to jump forward to your question. Sorry, John. But so are you saying that this marker that you're talking about is not sufficient and you're still working in this area?
No, this is, this is not the goal that you overlay, that to use it for during overlay. Surgery. It's just for like having, if you have a multiple user session within, for instance, a surgical planning scenario, or within teaching, that you all have the objects at the same place, so to say.
Okay. And that's been a real interesting topic. And I think one of the things I'm interested in hearing from both of you is, what areas do you think, you need to move into now? What hasn't been solved yet that you feel is really fundamental? And probably from both of your perspectives, I'd be interested in having an understanding of that for the audience. Where do we still need genius? What areas haven't we cracked enough yet? Do you have a comment on that?
Yeah, I can start. I think one thing that's really interesting to me is that, I talked a little bit about replacing the displays, and, for me, it's not just about replacing the display and just sort of, putting in 2D versions in a 3D environment, right? So I think there's a lot of really interesting work to be done that really seeks to understand the best new interface, right? What does the new user experience and the user interface look like in augmented reality or spatial computing? Because I think, a lot of times when we see different examples or mock-ups, right, people really haven't reimagined the space. They've just, put stickers around of the same old content in the same old way, and mostly in the same place they were originally. So I think this is a really interesting area. I think it's also a very important aspect of really getting the sort of the buy-in of the people that are going to ultimately need to and want to use this technology. Because if you don't really optimize for how it fits into people's workflows, or fundamentally make the right changes so that it is sort of seamless, I think you're going to really run into issues there. So that would be something that I think is a really important and interesting area.
What about you, Linda? Any comments on like what nuts haven't you cracked yet? So that's like very HMI, right? Like exactly how do you, so just a comment on that, Jennifer, is the notion of the information overload that we put into our particular surgeons, right? Like to have to think of all the other stuff and how do you pull it together to them in such a natural way. But is there anything else, Linda, that you're thinking about? Like I like to talk a little bit about people wanting haptics, right? Like, so how do you, but I do want to, when I bring that question up around that, quote Walter Greenleaf, when we spoke to him, he was like, well, Julie, I think, we have a simplistic understanding even of where we're headed with that, because if you don't think AI is going to help us with a bunch of stuff, you're not thinking about the translational technology that we're really talking about when we talk about using AR, right? So, but I wonder, Linda, from Brainlab's perspective, if you could say, wow, I wish somebody would go out and solve this thing so that we could tie it in. Do you have any kind of any magic thoughts there? So.
I think the video that we showed kind of represents all the ideas that we have. So like step by step, I mean, for the planning, I think there's still a bunch of options or possibilities. So at the moment, we are just at the beginning, and I think there are more features to be implemented. Maybe at some point you can do the whole planning in mixed reality. Also, talking about these like remote sessions, also with COVID, I mean, we get used to it, to have sessions spread with computer remotely, sitting in different rooms,
like
that we can integrate it exactly,
kind of
that we can integrate this even in the OR. You have your headset on, then you kind of connect to I don't know, an expert living in a completely different country or something like that. So this is more in like the planning and teaching application, but also I think in a long-term perspective there's a high potential using this in the OR.
And I think people love to talk about these use cases, but the wonderful thing about this talk is that you're doing it, right? Like, so we talk about surgical consult, but this is where we're headed and you're doing it, right? So the other thing about the use for education is that the notion in surgical theaters in education is it's so expensive, the cadavers, just using the space. So then even if you didn't speed up the education, the access to doing it, say, as a first year in AR and as a third year with a real cadaver in a surgical, I mean, you're talking about really extending more knowledge that way, even in a regular setting, as opposed to even distributed education just in time when you need it, like into third world countries or something like that, to make surgeons where there aren't any, like that. All that area is really powerful, I think, with your solution. Okay, I'm going to get into some of the questions. I did have one more question that I wanted to take you to task on, Linda, when you talked about the gestures. So when you talked about using, not using the gestures such as something with the HoloLens, but throughout that explanation, you were using a handheld device. So, so I'm interested in, so either way, you're using your hands. So I maybe missed your point about that, or, like talk to me about that just a little bit. So.
No, I mean, we know the concept of like this is just an example is the HoloLens, where you have very often these box around the object, and then you can use the edges to move them, and to interact this with your hands. And of course, also here we have with the controller to help the controller, and but here we don't have to always kind of put it up and look at it, but you have very easily can even have your hand beside you and control the 3D object with the controller. It's not so tiring, and that you can see with the laser pointing that the laser pointing much easier what the others are doing.
All right. I was just checking that we didn't have some new
No.
type of controlling. I was like, wait, are you
No.
sending sparks out of your fingers or
No,
what?
no.
Yeah. All right. So let me
No.
get into the audience questions. So I don't want to,
Yeah.
I could corner you guys forever here. So, so we have some questions and I'm just going to head down through them in the order in which they were submitted. And so the first question, which is not surprising, is about FDA classification. So did you obtain clearance as a medical device? Is it a class 2, class 2A in EU? Is there anything you want to talk about, like the classifications in that area? That's for Brainlab. Sorry.
Yeah. So for the viewer, we have CE and FDA clearance, and to be honest, I just have to. I think it's class. Oh, it's embarrassing. I have to check. I think it's class 1.
Oh, class 1. Okay.
Class 1, class 2, class. Yeah. I sorry. I have to check this.
Now, is that on your website? Can people just go take a look at that? So that just
I
as a
think
statement
so,
or
yes.
something. Yeah. So, all right. So we can come back to that. No worries, and we'll
Yeah.
get some follow-up data around that. And I know that people will be interested in that process, so I don't know how much time we can put on that, but we've got a lot of questions here. So the next person, James, is asking about the comparison between Magic Leap and HoloLens in the context of the Brainlab application. You're probably a professional explainer of the difference in this area, Jennifer. So, yep.
Well, actually, I mean, I think it would be great for Linda to add her thoughts, especially since Brainlab is really developing on the platform. So I'd love to see that. I think it's probably the best way to answer the question.
Sure. So Linda, you want to talk about the difference, the compare and the contrast between the Magic Leap and the HoloLens?
And so
for your use case.
For the application, you mean?
Yeah.
So for the current use case, I mean, we see a high benefit, of course, in Magic Leap. So starting from the headset, that it's it's less weight than the HoloLens, and as I said, with the controller, it's much more intuitive and user friendly having this than having the gestures. Also, the field of view is slightly a bit bigger than with the HoloLens. And also what is very important to mention maybe is, of course, for all these, what we are doing in healthcare, I mean, this rendering, and there's a lot of calculation involved. And I mean, there's a back end where most of the calculations are done, and then it transfers to the headset or to the device. And the Magic Leap has this little light pack as a computer, which is much more powerful than the version of the HoloLens at the moment.
That's great. Thank you. And I'm gonna go to Thomas and say, I appreciate it. I think Thomas was asking a very similar question about the paper that I was, but he was talking about sterilization. And so have you moved into the use in an environment where you need to consider sterilization? Is there any concern around that in the use of the Magic Leap with Brainlab's applications on it?
So, I mean, for the current application that we're talking about, it is a surgical planning application, so it's used,
so no
outside of a sterile environment. But we have, as a company, right, we've looked at all of the standard types of cleaning practices that would be required, and there really aren't going to be any issues with that. And certainly, as you move forward, when we do look at use cases that are more focused on sterile settings or an operating room, right, there will be appropriate procedures both for the cleaning and then also for things like drapes if necessary, right?
And I mean, surgeons wear all kinds of stuff on their face, so there's a process for this, so
exactly.
But,
And there's also lots of very delicate equipment that is already being used, right, in these settings, right? So there's very there's a lot of precedent, right, for cleaning and the protocols used around these types of things.
Okay, and we have a question from Charles about sharing your models. Can you share your models or have a group interact remotely to consult or something like that with such as spatial IO? So he's asking about model sharing, I think with Brainlab.
You mean model sharing, that you have like a remote session, so to say? Yeah.
Probably the collaboration component that we were talking a little bit about.
Yeah. So at the moment we don't have this. I mean, with the product that we have, it's currently possible to have it kind of remotely. But there the prerequisite is that both headsets and the device where you have the viewer installed have to be in the same network. So you can share the QR code, for instance, via your smartphone to the other one who is in another room, but you have to be in the same network. But we are working on a solution to provide this also beyond local networks, so have this available also, like, between people at different locations. And also one comment, so for the medical device class, it's FDA class 2 and CE class 2.1. Sorry, I was a bit confused.
So it is 2 and 2, 2.1.
2 and 2. Yeah.
Yep. Great. So I'm going to go, I did talk about John's question a little bit, but he was talking about controller drift in a magnetically variable hospital environment. So understanding that, how to get high accuracy, I think we covered that a little bit, but did you want to make any more comments about that? Or we might have already covered that. So let me move to the next one. So from Jeff, we have, what are the problems and limitations of stereoscopic display that cause Brainlab to move to Magic Leap? So he's interested in that. If you have a comment about that, that's a pretty tech question. So yeah.
Repeat the question again. I didn't.
What were the problems and limitations of the stereoscopic display that caused Brainlab to go to Magic Leap?
Okay.
It feels like as opposed to using the HoloLens or something like that, but I'm not sure. That's all. That was the end of the question.
So I think that why we moved to mixed reality, I think what I said at the beginning, I mean, with the stereoscopic display, you also have to wear a glass, and I think the depth perception is already quite good, but it's still like not, you want to interact with the model, but you can't. And then we thought about, maybe the benefit is not as high as that it's like sellable all around the world, and we should go even further to, this is kind of a solution in between. I mean, half screen and then half reality. And I think with mixed reality, you get like the full package.
Yeah, I think the key is, right, that once you move over to augmented or mixed reality, right, you suddenly have the ability to tap into many other use cases, right, with the same display. And so, you know, if you look back at the quick video that we showed, just thinking about what that really means, right? It's visualization of monitors, it's controls, things like that. So there's a whole host of other use cases that you can apply with the same head-mounted display, which just, you know, wouldn't be possible in these 3D stereoscopic displays.
So I think this is really tied, and we can make a quick comment on John's next question, is characterizing the value of doing this in spatial computing, mixed reality, rather than just using virtual reality. So he's saying, you know, from experts, do you have a way that you tend to describe mixed reality versus virtual reality to talk about this, to make it clear? And also I'm going to remind you, John, that we had an opening talk on this way back last year that you might want to go back and take a look at on the differences. But do you have a way that you like to put that in brackets, kind of thing?
Yeah, I mean, I always make the explanation, because we also still, you know, there's still a lot of confusion, right? And a lot of times the terminologies are used interchangeably when people don't really mean it that way, right? But I think the fundamental part of this, right, is that you are not cut off from the real world when you're talking about augmented reality or spatial computing. You can see the real world around you. And I think the other really important factor is the fact that the digital content isn't just an overlay, right? It isn't just a sticker. It is aware of its surroundings when it needs to be, right? And depending on the use cases. And so this idea that the digital and the physical worlds are interacting with each other is a really important one when you start to consider these more complex use cases that go beyond visualization, right? Because I think you could probably argue that in some cases, if all you're doing is viewing a 3D model, maybe VR is fine, right? But if you look at that big picture vision that Linda and I showed, you really need you know, spatial computing to enable all of those use cases in the longer term.
Yep, great. Okay, so from Larry we have, will you be able to show flow in vessels? So
in mixed reality?
So in your solution, I think he's saying, are you going there? Are you doing it? Are you showing flow in vessels? So you know, that's a hard area,
Not
particularly
at the
during
moment.
surgery, right? So, okay. So that's a question we get, you know, how to model flow just because it's the body's so dynamic. So it comes up quite a bit of like, and it also ties to haptics sometimes for us. So when we get that question, we're trying to understand ourselves as experts on how to get to some of this. So, okay. Let's see. Okay, Microsoft has a similar concept for the marker called spatial anchor. Oh, okay. I think that, I'm going to keep going here. Let's see. Okay, I have a question about the use of the standard regarding the device itself as well as workload. I'm not sure I actually understand that one, Michael. So he's got a next one. Let's see. He's inviting you to join an organization. I'm doing this live, which is really cool. He has an ad hoc ISO international ad hoc work group. So
Reach out to us. You got our emails.
I'm your talk secretary here. So let's see. Pardon me while I just try to get through these quickly here. So actually, I think this is an interesting question right here. So when you talked about the FDA, are you certified now or are you in the process?
You mean me? Oh,
yeah,
the
Brainlab. Yep. Is it in the process of getting 2 and 2.1 or 2A, or are you in the process?
It's cleared.
It's cleared.
Yes.
So they're cleared.
Yes.
Yeah, since January, right? So last year. So it's almost a year now, or over a year now. Yeah.
And do you want to just talk about that process for just a moment? Not your details particularly, but what was that experience like to go through that process? Can you share a little bit about that?
I can't share anything, to be honest, because I wasn't in the company.
Sorry. So that's one of the questions that comes up often. People want to talk about this
and
process.
Also, I mean, in general, we can't talk about regulatory processes.
Okay, and we had a really nice talk with the FDA here around vision, right? A particular expert there that worked with different headsets and talked about how different they can be, you know, like how the offset can be different on different headsets. So do you want to talk a little bit about that, Jennifer? Have you been in enough meetings that have or worked with enough clients and partners going through the
I mean, I'm not directly involved in the partner submissions. Yeah.
All right. Good enough. I know I can tell the audience myself that my research in the use of AR has been identified as a medical device by the FDA, and I had to put all my research into that too. Just the research, just to do the clinical trials, which is totally different than being certified. But and that was a fast process. So for people that don't know that process at all, software as a medical device, just to get identified and make sure you're keeping them informed is very quick, and they're very sharp.
Very nimble, right?
They're
process.
Getting, yes. Yeah. And I mean, kudos, like big, because we've all figured it would be very arduous and they're working hard on that. Right. So, okay. So I have another question in the chat that I just saw, and even though it's not in the Q&A, sorry guys, but I'm wondering if you have modules and examples where teams from different locations could collaborate together with you. And I think this is about the workflow of the Brainlab products. It's reading like that a little bit. So I wonder, let's see, this is from, let me see who this is from. And maybe they can help us a little bit. Doesn't say who it's from.
I think Linda did explain that with the Brainlab application that they currently can collaborate on the same network, so people can join together. You know, at Magically Bright, we're also working on the functionality that enables people to collaborate regardless of whether they're on the same network or not. And this is the communication, collaborations, and co-presence solution suite that we're working on. We're using it today as teams internally, and it's a great way to, you know, especially in this new environment where everybody is working at home, regardless of what network you're on, wherever in the world you are, to be able to collaborate together in 3D, you know, either in a co-present 3D spatial kind of way, or as an avatar, or with 2D video conferencing as well.
All right, so I have a couple more questions, and thank you for reiterating that. One is asking whether or not haptics is on a roadmap, and I don't know whether that's to Brainlab or to Magic Leap. It's probably good for both of you to comment on that.
Yeah, I mean, I can start. Of course, with the controller, it's nice for the current use cases, but especially in the OR, if we work in the sterile field, or also for other applications, it makes sense to also implement some gestures or some alternatives that can be gesture, eye tracking, stuff like that.
Great.
Yeah, I mean, we get questions about haptics all the time, both with, people that are enthusiastic about it, right? And then others that are sort of questioning it in the current context of like a surgical use case. So, definitely work being done in that area. I don't really have anything specific to report, but as Linda said, particularly when you think of the more sterile environments, right? It is important for people to recognize that the control that the Magic Leap device has is a really great way to interact with the content. It's super accurate. So I think it's differentiating from that perspective, but that doesn't mean that's the only way that you can interact with the content. And, we've seen lots of great examples of people using the latest updates of our software, right, that enable gesture and voice, and then things like eye tracking, right, to follow the content. So I think there's a lot of really interesting possibilities there, depending on what people want to do.
You want to take a minute on that, Jennifer? There was a question about with Magic Leap, how do applications look, or how are they loaded and maintained? So that was a little bit tech straight up.
Yeah, and I mean, I can let Linda explain what Brainlab does, right? But really, in the Brainlab example, Brainlab is loading the software onto the device and providing it to their customers, and so that's the distribution model that we've been using with partners.
Yeah, it's like in the App Store on your smartphone that you kind of can imagine, and it's like also very intuitive. So in our case, the user puts on the headset, turns it on, and then he has a kind of a menu where he see all the apps installed, and then you have this. For us, it's a small Brainlab logo you just have with the controller selected, and then you're free to go. And it's, I think, very similar to what you have on your smartphone with an App Store.
So is it a kit, like you pre-install it and send it as a full up kit like that?
Yeah.
From Brainlab. Okay.
Yeah.
So
yeah, it's a bundle.
Yeah,
great.
exactly.
Super. Okay, so let's see. Yeah, go ahead.
I was going to add, that enables things like provisioning up front and, certain features and settings to be, pre-selected as appropriate, right? So there's a lot of interesting things that people can opt to do with that, depending on how they want to, deliver their solution to the market.
Mm-hmm. You can imagine like two different solutions on Magic Leap and wearing two different headsets, so as it grows. I already do that with different things now with VR, so it's like pull it up, lift it down, right? So let's see. There's another one. So maybe I think we're at the end here, but I'd like to just say sort of last word to speakers. Like, is there anything else you want to talk about, like next steps, something hard, last word, last word, what didn't come out right here, or something that you want to tell the audience?
Well, I mean, I think you can see that both of us are really excited about all the work that is going on. And I think, the example that Linda showed from UC Davis is a great one, because I think it brings home the fact that, this is an enabling technology that really can actually fundamentally change people's lives, right? It's not just, I think, the quote was about gaming, right? It's not a toy, it's not a game. It's something that really can be used to change how healthcare is delivered, and that means a lot of different things, right? It means, efficiencies and maybe cost reduction. Certainly means, I think, increased access to care, and it really potentially has the opportunity to enhance, patient outcomes as well. So I'm really excited about it. And, I look forward, Julie, to coming back and we can talk some more in, 6 months, 10 months and see what else is going on.
How about you, Linda?
Yeah, well, I think what makes this so special, also beneficial for the for healthcare, is, I mean, medicine is not like you have a surgeon deciding on a certain treatment or doing this diagnosis. It's all about interdisciplinarity and like working together as a team. And I see a high potential or high benefit of this when I also talk to surgeons, that they can put on the headset and discuss this case yeah, together, or if we think in a few months, then remotely from US, Japan, wherever they are. And also, I mean, not for planning, but also in the OR, I mean, you can also think about different scenarios where you have, you need assistance, you are running into a problem, you need someone, and then with this headset communication, it's so much easier, and you get all your information that you need within a headset without looking in the OR at 20 screens or even more. And this is, I mean, there's still a lot of things that we have to explore and also make it work. But if you look at smartphones, I mean, how we started 20 years ago, the first smartphones that came out, and now how they look. And I think this is kind of with mixed reality. We are just at the beginning, but yeah, as I said, I think in medicine with this interdisciplinary field of action there, I think it's a great tool to use it.
And I have another technical question that came up that inside the solution that you're working on, and maybe it's a combination answer, is there an underlying gaming platform? I mean, are you using Unity in that layer underneath, or Unreal, or is there something in particular that you're using that's the glue? Is it all Magic Leap, or is there something else that's this sort of middleware component?
So for Brainlab, it's of course Magic Leap features, but also Unity that we.
Yep. And so, I mean, I think sometimes when we do these, we've done these talks, we forget that layer right there is really powerful in that we have this sort of what we used to call middleware, you know, years ago in software, right? So that's, and the reason why I bring that up is because people have been asking about VR versus AR, and the notion that what you build there can easily be reused in different ways if you have kind of different capabilities that you need from it, you know? So yeah, okay, so that's really interesting. And I have a couple other questions, I think, in chat, but I think we've gotten to everything. And I just want to tell everybody, the audience, thank you for such wonderful questions. And then, of course, our speaker's amazing. And we do want you to come back in 6 months or a year and tell us what else is going on. So thank you very much, guys. A little bit of housekeeping. You can go to medvr.io and see the talks. And you'll hear from us on the next one. So thank you, everybody, for coming. And I'm going to end it out now. Thank you, guys.
Thanks, everybody.
Thank
Bye-bye.
you.
Bye. See you soon.
Bye.